Oh, I just remember they said to you.
It's the one that started it.
Okay, what we're going to do today is we're going to do some problems that use these properties of similar triangles that we've come up with before, and it's called indirect measurement. And what they mean by that is you can use similar triangles to measure something indirectly, in other words, without like actually putting a ruler on the object itself. And this is an extremely useful part of similar triangles. And so if you're ever driving down the highway and you see the dude that's holding the thing there, and then the other dude that's looking through the thing on the tripod, have you seen that before? And they're surveying, what they're doing is they're making measurements, and then they're going to take those physical measurements and go back to the drafting room or whatever, and basically, this is a little bit simplifying what they're doing, but they're basically going to use similar triangles to figure out the measurements that they need to make to build a new road or fix something or some such thing. Yeah, like that, okay? And so what we're going to do today is we're going to figure out how you can use similar triangles in a couple of different ways to measure the heights of things that you might not be tall enough yourself to measure. So for example, if you wanted for some reason to know the height of a flagpole, obviously that would be a difficult thing for you to do with a measuring tape or a meter stick or something like that, because you'd have to climb up the flagpole in order to be able to measure it, okay? Yeah, I know, you only get one a day. And so here's one way that you could do this, and if we lived somewhere sunny, like Santa Barbara or some such thing, we could go out and do this as a class with those things out there. But it's pouring rain outside, so we're going to stay inside and just talk about how you would do it. There's a couple of different ways that you can do this. One is you can go out and you can stand somewhere on the road or on the sidewalk or whatever. Okay? So here's you. Okay? Is that kind of too tall of a flagpole? Should I make that person bigger?
Yeah.
A little bit?
No, that's like fine.
That's fine? We're good? Okay.
If it was me sitting next to it, I'd probably be taller.
Okay. So I'll have to exaggerate this a little bit to make it fit. But what you can do then is you can take a mirror and lay it on the ground and have another person keep moving that mirror until you can see the top of the flagpole in the mirror. And if you do that, what you have created, here's your line of vision. Like I said, this isn't going to be exactly correct. And then here is your vision bouncing off of the mirror to the top of the flagpole. And what have you constructed? Two triangles. And what's true about these triangles? They're similar. How do you know that they're similar? What angles do we know to be the same in these two triangles? Okay, good. First of all, you know this right angle right here that the flagpole makes and the right angle right there, because you're standing straight, okay, are going to be the same. But we need more than one angle. What's the other angle? This one up here with that one right there? How would you know those are the same? Which ones? On the bottom, yeah. How do you know that these two angles are the same? I mean, you're right, these two are the same, but these are the easy ones to figure out why. Why are those the same? How do you know that, though? Yeah, because when a light bounces off of a mirror, it comes off at the same angle that it goes in. Okay? That's a property of light that you learn about in physics. So you have two similar triangles. Okay? So if you know, for example, that we'll just do some easy measurements, that this person is 6 feet tall, and they are standing how far from the mirror? 3 feet. What? 3 feet. Okay? That is crazy. I mean, there are so many numbers out there. What are the chances of that happening? Like 0%, which means it actually didn't happen. And it's impossible. So you're lying. So go to the office. Okay. Don't say it, think it in your head. Greg? How far is this mirror from the flagpole? 15. Oh, he was thinking 21. Okay. All right. Then we can very easily set up a proportion and use that to figure out the height of the flagpole. What would that proportion be?
3 over 15.
3 over 15. So Rich is going with sidewalk over sidewalk equals
6 over 8.
right, tall person over height of flagpole. Okay? And so how tall is the flagpole? 30 feet tall. Yes. Or if you wanted to, there's a lot of different ways that you could set this up. You could go 6 over 3 equals h over 15, or, you know, we've seen that before, that similar triangles work out in a lot of different ways. Does that make sense? See? Okay. Then there's another one that we definitely can't do in this climate because it involves measuring your shadow.
Yeah.
And in this case, what you would do is,
like a puddle or something?
Yeah, can you measure your puddle? No, I don't think so. So here's you. Here is a lamp post that you want to know the height of for some strange reason. And it's a sunny day. And so the lamp post casts a shadow, and you also cast a shadow. Okay? And so once again, what do we have?
90 degrees.
We have a 90-degree angle. Okay, now I have not technically made a triangle yet, so I need to probably make a triangle right here and a triangle right here. In this case, since you're talking about a shadow, what is the other angle that you know to be the same?
The bottom.
The one on the bottom?
The height.
I'm thinking the one at the top here, because the angle that the sun hits you both, the rays of the sun, those two angles right here and right here are going to both be the same. Yes? Uh-huh. And so in this case, you can measure the height of the flagpole by, if you know your height, and this one is 5 1/4 feet tall, you can measure your shadow.
What?
I was going to see if she was going to name a number. 6 feet, okay? And then the shadow of the flagpole is 18 feet. And so quite simply, how many times greater than your shadow is the flagpole shadow? 3 times bigger, so how many times taller is the flagpole? Right, so the flagpole would be, or light post I guess in this case, would be 15.75 feet because it's 3 times as big as your height. Okay? So there's a couple of different ways that you can do that. And so what that means is we are going to do your favorite kinds of problems.
Word problems.
Word problems. When are we ever going to use
Excuse
this?
me.
Well, here it is.
We're going on strike.
Yeah.
That would be awesome.
Why'd that be awesome?
It would make my job so much easier.
Just go straight ass or something?
Yeah. What do you think?
Please go to the restroom.
Uh-huh.
Do I have to wait for her?
Why can't you just give us A's and then not work too?
You're doing 1 through 4, right? Oh.
Okay, the key here for these problems, do not be lazy, okay? Don't just read the problem and then come up to me and go, I have no idea what this is saying. Draw a picture. Find some triangles, okay? And then I think you'll be able to figure these out without too much trouble.